Hi, welcome back to CNU Informatica. This is your Srinivas. Today topic is two-stack push-down automata. It is a very powerful machine than PDA. That is single stack push-down automata. To overcome the limitations of PDA, they developed the two-stack push-down automata. A little complex and advanced machine that push-down automata is two-stack push-down automata. In the normal pushdown automata, we are having only the single stack to store the alphabets and symbols. Few of the languages are not solved by using pushdown automata, which can be solved by using two-stack pushdown automata. Why do we need the complex machines? Means if we consider the finite automata, it can recognize only the regular languages like L equal to A power n, that is plus z n greater than or equal to 0. It has some limitation, so that to overcome that finite automata, they introduced the pushdown automata. The pushdown automata is going to recognize only the context-free languages. Like the language should be the A power n, B power n is greater than or equal to 0. It is also having some limitation of the pushdown automata. But some of the more complex languages like A power n, B power n, C power n greater than not equal to 0. Our regular PDA gets stuck here to solve such problems. To overcome this type of problems, we need two-stack pushdown automata. It is a powerful version of a PDA. The two-stack pushdown automata represents a more powerful variant of the standard PDA. Instead of having a single stack, it uses the two separate stacks for the memory storage. Two-stack PDA may operate in a deterministic manner, choosing a unique transition at each computational step. That means, similarly as a finite automata, we are having the initial state. By reading some alphabet, it moves to the next state. That reading value will be pushed into the stack, either in a stack 1 or in a stack 2. This model is capable of recognizing every context-free language, including those that are not handled by the deterministic PDA, that is single stack PDA. Furthermore, a two-stack PDA can recognize certain context-free languages, such as the language A power n, B power n, C power n, which is a standard PDA cannot process this problem. The components of two-stack PDA. It contains the 9 tuple in a 9 tuple in a two-stack PDA. The machine defines as Q, sigma, tau dash, delta, Q naught, Z1, Z2, and F. Whereas Q is the all states that PDA can be in. That is set of states, we can say that. Sigma, the input alphabet or symbol, it can be read. Tau, the alphabet for the first stack. Tau dash, the alphabet for the second stack. Delta, that is the transition function, moves the state from one state to another state and using the stack. Q naught, the starting state or initial state. Z1, the bottom symbol of the first stack. Z2 is the bottom stack of the second stack. Bottom symbol of the second stack. F is a final or accepting state, we can say. This is the working of the two-stack pushdown automata. It contains the input tape. The input tape is going to dividing into the equal squares. Each square holds a single symbol or alphabet. And to read that string, we need a header. Read write header. It moves from left to right. While reading, it can have the final state control unit. It sends the alphabet or input value to the stack 1 or into the stack 2. The transition function delta is the main thing in an automata. Here, for the two stack pushdown automata as well as, it looks like this. Here, from the transition delta maps q into sigma union epsilon into first stack, that is tau, into second stack represented by tau dash, gives q comma first stack input values and second stack tau dash alphabets or symbols. This indicates it considers the current state, the input symbol, and the top symbol of the both stacks. Based on this, it decides the next state and what to do with both stacks. Right? By considering example, clearly we can understand how the two stack pushdown automata is going to be working. Here I'm going to designing the two stack PDA for the language A power n, B power n, C power n greater than or equal to 0. This language has an equal number of A's, B's and C's in that order. Here the strategy of this language is, while reading A, we will push X into the stack 1. That is, A is going to converting into X and push into the stack 1. While reading B, we will push Y into the stack 2. Okay. After that, we are going to reading the C. We will pop top of the stack 1 and stack 2. That is X and Y from the stacks. If both stacks are empty at the end, we can say that the string is accepted by a two stack pushdown automata. Let us see in the diagrammatic representation of working with A power n, B power n and C power n. But initially we have the tape with empty and two stacks with a initial value Z1 and Z2. If I am going to reading the epsilon from the input tape, that the transaction will be looks like this. Delta Q naught at the initial state, I'm going to reading the epsilon. Z1 is the stack symbol, Z2 is the second stack symbol. Gives to the output transaction is QF. By reading the epsilon, it reaches to the final state, comma, there is no change or not pushing or popping operations is done here, so that as it is the Z1 comma Z2. In the finite automata, while designing finite automata, by reading epsilon, directly it reaches to the final state. In the similar way, here also it is going to reaches to the final state. Clear? Now we are considering the string in a input tape. Let us see how we are going to draw the transition diagram. Initial state is Q naught. By reading epsilon, top of the stack S is Z1, top of the stack 2 Z2 is S is Z2, and moving to the state F2. Right, we are writing that reading input value, moving to the stack 1 and stack 2 values here on the transition. Clear? Now I am going to considering the input string here. The input string is AA, BB and CC. Now the header is going to reading the A. The transition will be delta q naught comma a comma z1 comma z2. Initially the stacks are empty. After pushing a into stack 1, that is a is converted into x. Now the top of the stack will be the x for the stack 1. Stack 2 is empty. Let us see how we are going to representing that in the diagrammatic way. Now the a has to push into the stack and converted into x and placed in a top of the stack of stack 1. Clear? It is placed on the top of the stack 1. Clear? Now the header will move from left to right. That is, now it is going to read the second A. Right? The transition is, here we are not changing any state, so that it's self loop. The input string is A. In the stack we are moving X. There is no change in the second stack. Now the header will read in the second A. Here second A. The transition is delta q naught comma a comma z. Instead of z, the top of the stack is x. Here we have the top of the stack is x. So x comma top of the stack of x, stack 2 is z2. Gives the output transition is q naught comma a is converted into x, so that the top of the stack is placed with x, so that we have the, in the stack 1 we have the 2x. So 2x comma, that is xx comma z2. Clear? Now see how the representation, how the conversion is going into the representation in the diagram. A is going to be converted into x and placed in the top of the stack on the x. Now the top of the stack is x. That means we are not changing the state, so that itself loop we are going to be representing a comma z1 comma xx comma z2 comma z2 z2. Now the header will move to next position, that is by reading the b value. Now reading the b here, the transition will be delta of q naught comma b comma x comma x2. The input is reading b. The top of the stack 1 is x. Top of the stack 2 is z2. The output transition is same state q naught comma x comma. Now we are reading the b, so that is the second type of input. The first type is a, we can say that the second type is b, so that the second type of symbol b is pushed into the stack 2. So the b is going to converted into y and placed in the top of the stack 2. Now let's see in the diagrammatic representation that the b is going to be changed into y and placed in the stack 2 top. Here now the representation in the diagram is itself loop with b comma x comma x comma z2 comma y z2. The top of this stack is x and we have the y z2. Here now the header will move to the next b. Now the header is reading the b. The transition is delta q naught comma b comma x comma y. Y means here the top of the stack is y, so that B is converted into Y and placed in the top of the stack. So that Q0 comma X comma X6. Clear? Now the header will move to next reading the C value. The transition is delta Q0 comma C comma the top of the stack is X, second top of the stack is Y. Now we are reading the C. Now we are going to comparing the two values of stack A and stack B are going to be popped. So first C is reading, so that we're going to popping the stack 1 value and stack 2 value, so that it is going to the next state, that is Q1. In the stack it contains the empty, that is epsilon, or we can represent as lambda. Now here in the transition diagram we draw that for the input C, X will becomes to epsilon, Y becomes to epsilon or lambda, moving to the state Q1. Clear? Now the header will move to the next. The transitions, the state is, we are at the state of Q1, so that Q1 comma reading C, the top of the stack is X, here the top of the second stack is, and then the top of the stack is Y, so X comma Y. Now reading the second C, again we are going to popping off top of the stack of X and Y. Now we'll get the Q1 comma epsilon epsilon or lambda lambda. That means itself loop, we are going to get it is in the same state, that is the Q1 state. So that we are drawing the itself loop by reading the C, X becomes epsilon, Y becomes epsilon. Next, we are not having anything that is epsilon, so that the final transition will be like this: delta comma lambda or epsilon Z1 comma Z2. Now while reading the epsilon, it moving to the state F2, F1, sorry, QF, that is final state. The stack, both the stacks are empty. The representation is like this, and we are going to draw the path or transition between the Q1 and F1 by reading the epsilon. Right? Now we can say that the both stacks and the input tape is empty, so that the two-way final two-way pushdown or two-stack pushdown automata is accepted this language. Why two-way stack is more powerful means they can recognize all context-free languages just like a regular PDS. They can also recognize some context-sensitive languages which regular PDA cannot. In fact, the two-stack PDA are equivalent to the Turing machine. Whatever the problems is solved by the Turing machine can also be solved in two-stack by using the two-stack PDA. This means they can compute anything that's computable. This equivalent is proven by something called Minsky's theorem. By using this Minsky's theorem, we can say that it is equivalent to be proven of two-stack PDA. I hope that you understand the concept of two-stack pushdown automata, why it came into the exist, what type of problems were going to be solved by using the two-stack PDA in the graphical representation. Thank you.